Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everyone, thanks Jason for that amazing intro. I'm so glad that you guys are all here with me. I recognize some familiar faces from last week, which was our first session ever. We had some technical issues last week, but we are good to go this week. I noticed that some of you have already said hello. If you haven't said hello already, type in the chat box, say hey. Let me know what exam you're prepping for as well, just to give me an idea of who's in the room, what exams we're looking at, and all of that. Just a quick disclaimer that I like to do anytime I do a live session from home. We do have a very big dog, and he barks at squirrels and FedEx guys and all of that. So hopefully he doesn't bark, but if he does, or he shows his face, that's Pudge. That's who it is. So just like to give that disclaimer. Hey everybody, so we're gonna get started with the first question. I see that some people are prepping for general knowledge, K-12, ESE. This is focused on the math portion of any of those exams. So if you're here and you're prepping for a reading exam, I'm glad you're here, but we're not going over any reading questions today. We're only going over math questions. So glad to see you all here. Let's get started with the first question. So we have this first problem is simplify. So when we have a problem like this, we know that we're trying to simplify this expression. We know it's an expression because there's no equal sign. Expressions don't have equal signs. Equations have equal signs. And I remember that because equation pretty much has the word equal inside of it. So you've got expressions and you've got equations. When we're simplifying either of those, we need to use PEMDAS or order of operations to simplify. So we're going to use the order of operations to simplify any type of expression or equation. And the order of operations, like I just said, is PEMDAS. Please excuse my dear Aunt Sally, where P is parenthesis, E is exponent, M is multiply, D is divide, A is addition, S is subtraction. One really common misconception is that multiplication has to come before division, or addition has to come before subtraction. That's not true. Multiplication and division are married, and addition and subtraction are married, which means you can do multiplication or division as long as you've gotten past parentheses and exponents. You can do multiplication and division in whatever order, as long as you're going from left to right. We read from left to right. We do math from left to right when it comes to order of operations. Same thing with addition and subtraction. Once you get to the addition and subtraction, you solve left to right. So let's get started with this problem. We have 3 minus 9 in parentheses times negative 2 plus 3 in parentheses divided by 3 minus 5 in parentheses. So what I'm going to do is I'm going to solve my parentheses first, because in order of operations, parentheses comes first. So 3 minus 9. Now, if you're taking an exam that allows you to use a calculator, you can absolutely use a calculator to do basic computation. I would not suggest plugging all of this into a 4-function calculator, because 4-function calculators don't understand order of operations. But if you don't know what 3 minus 9 is, or you're not confident in your ability to add and subtract integers, you can throw that into a calculator and just get that piece of it. So we know that 3 minus 9 is negative 6. And then I'm going to keep everything else the same. Hi, Daphne, prepping for math 6 through 12. Awesome. So negative 6 times, I'm going to keep everything else the same. Then I'm going to solve the next set of parentheses, because again, parentheses comes first. And I apologize about the delay between what I'm saying and the screen. I don't know how to fix that, to be honest. Jason and I were talking about it earlier. We'll try to fix it. But I apologize for that delay. So negative 2 plus 3 is that next parentheses. So I'm going to go ahead and solve that parentheses. Negative 2 plus 3 is 1, positive 1. I know that because as I move across a number line, addition moves us in the right direction. Subtraction moves us in the left direction. So if I have a number line and I have negative 2, negative 1, 0, 1, 2, and I start at negative 2 and I'm adding, which means I'm going to the right, I'm going to end up, if I add 3, I'm going to end up on a value of 1. So negative 6 times 1 divided by, parentheses, 3 minus 5. Negative 6 times 1 divided by 3 minus 5. Then I'm going to solve that final parentheses, because we've solved the first set, we've solved the second set, and now I have to solve that last parentheses, 3 minus 5. And 3 minus 5 is negative 2. And so I'm going to solve that, and then I can move on from that parentheses in the order of operations. This is a problem that you really could see in an elementary test, because students start learning about order of operations in 5th, 6th grade. You could see it on the GK math. You could see it on a middle school or a 6 through 12 exam. So this question is one that you really could see across all grade levels, because it's right there on that 5-6 border. So now I have negative 6 times 1 divided by negative 2. And now all we have left is multiplication and division. Multiplication and division, remember, are married. So in this case, I'm actually going to do multiplication first because it's on the left. But if the division came first, I would do the division first. Negative 6 times 1 is negative 6 divided by negative 2. And negative 6 divided by negative 2 is a positive 3, which gives us B as our answer. Give me a thumbs up if that was comfortable, if you understand what I did. I don't care if you know how to solve that by yourself today, but if you understand what I did and why I did it, that's the goal for today. So, hey everybody who's just now coming in, it's so good to see you. My name is Amy Sink and I'm your math specialist here at the Learning Liaisons. And we just finished problem 1. So if you're just getting here, we've still got some more problems to do. All right, let's move on to problem 2. A square playground is built using 288 yards of fencing. About how many square feet does this fence contain? All right, we've got quite a few concepts being addressed here. The first thing that I notice when I read this problem is that the problem starts in yards, 288 yards of fencing. But then it asks us for square feet. How many square feet does this fence contain? So we started with yards, but now we're ending in square feet, which means we're going to have to do a unit conversion. So the first thing I'm going to do is convert those yards into feet. So I'm going to draw a picture because anytime we're dealing with a shape or a word problem, I like to try to draw a visual picture to help me visualize what's happening. Even now, to this day, I still draw pictures. Square playground. So I've got a square. Probably looks a little bit more like a rectangle, and that's okay. But I know it's a square. What do I know about a square? A square has 4 equal sides, exactly. So I know that this side is equal to this side is equal to this side is equal to this side because it's a square. What do I know then about that square? I know that we have 288 yards of fencing. Well, if I have 288 yards of fencing, that means I fenced around that square using 288 yards. That means that the distance around my shape is 288 yards. What is that called? That's called perimeter. Perimeter is the distance around a shape. It's not the area. So perimeter is going to be your fence. Your area is going to be your grass or the paint or whatever. And in fact, it asked us for the square feet. Square feet meaning area. So I have 288 yards of fencing, and I need to figure out how many feet that is, and then I need to figure out what each side is. Well, I know that 1 yard equals 3 feet, so I know that 288 yards equals, I'm going to pull out my calculator for this one, 288 times 3, because 1 yard is 3 feet. 1 times 3 is 3. So 288 yards, 288 times 3 equals 864 feet. So that's how many feet of fencing I used. Now, I'm going to divide that by 4. Why am I going to divide that by 4? I'm going to divide that by 4 because I have a square. And a square has 4 equal sides. Thank goodness I don't have a rectangle because then I'd have to do something else. A square has 4 equal sides. So if I divide 864 divided by 4, I'm going to get the length of one side. And you'll see why that's important in a minute. 864 divided by 4. If you didn't have a calculator on your exam, you'd have to do this by hand. But I have a 4-function calculator in front of me, so that's why I'm using it. So 864 divided by 4 equals 216 feet. That number represents the length of one side of each of the square. One length of each of the sides of the square. Yes. So we have 216, 216, 216, 216. Why was that important? Because I know it said, how many square feet does this fence contain? Square feet, meaning I'm looking for my area. Area equals length times width. So I needed my length and my width of my square to be able to solve this. Well, if area equals length times width, I can do 216 times 216. 216 times 216 equals 46,656, which is C. You are absolutely right, Courtney. Good job. The reason I don't convert at the end is because you then have to take into account square units, and that just gets real messy. So I mean, it's possible, and if you like to do it that way and you can get it right every single time, do it. But I like to convert on the front end with my linear measurements rather than on the back end with square or cubic measurements if I'm dealing with volume. This is another problem that you would see. You could see it in elementary depending on where you're taking it. You're definitely going to see a problem like this on middle school, GK, core, anything like that. All right, problem 3. And as I present these problems, feel free to work ahead of me and solve them if it looks like a problem that you know how to solve. This problem is a classic middle school GK core kind of problem. Let's go ahead and dive right into it. A farmer needs to compute the volume of his barn for storage purposes. The barn has a rectangular base measuring 32 feet by 15 yards and is 4.5 feet tall on two sides and is 12 yards tall from base to peak. What is the volume of the barn? So many numbers, so many different things to think about. Let's start with just breaking this problem down. What are we trying to find? We're trying to find volume. So how do I find the volume of a three-dimensional shape? Volume equals area of your base times the height of the shape. Where the area of the base, it could be a rectangle, it could be a triangle, it could be a pentagon like we have here. And you may have to work that out and then solve the rest of it. So in this case, I don't have a special formula for area of the irregular pentagon. So we're going to break that pentagon up into two shapes, and I'll show you how to do that in a minute. But big B is area of your base. Another big confusion is what number is the height? The height of a prism, which this is a prism, is going to be the distance between your two identical bases. A prism has two identical bases. Now, this problem may be found on a middle school GK core kind of problem, even high school. But I'm throwing information in here for all of my participants. Elementary people, you're going to need to know what 3D shapes are and the properties of them, which is why I'm throwing all this information at you. So if you look at this and you're like, definitely not going to need that, at least pay attention to those characteristics I'm throwing at you, because that's important for K through 12, those characteristics of shapes. It's what people always ask me questions about in our customer hub. So a prism has two identical bases, and then it has rectangles around it. So because this is a pentagonal prism, it has pentagons for the bases, and then it has 5 rectangles around it because the pentagon has 5 sides. The 15 yards is going to be your height, even though that's not how tall the barn is, because your height is the distance from one base to another base. So 15 is going to be your height. But what units are we going to use? We got yards, we got feet, we got all of it in between. The answer is in feet. So because the answer is in feet, I'm going to convert all of my linear yards into feet first. So I've got 12 yards here, I've got 15 yards here, and I'm going to convert both of those into feet. Well, we already talked about 1 yard equals 3 feet. So 12 yards is going to be 36 feet because I'm just going to multiply that times 3. So this becomes a 36, and 15 times 3, that becomes a 45 feet. Now let's go ahead and solve the area of our base. What we really have is we have a triangle on the top, and then we have a rectangle on the bottom. So we're going to find the area of the triangle. We're going to find the area of the rectangle, and then we're going to add those two together to find the big B, the area of the base. So let's go ahead and do that. I've got my pentagon here. And I know that the pentagon has a total height of 12. And I'm waiting for my screen to catch up because I don't remember where I drew that. There we go. So we have a total, no, not a total height of 12. I misspoke. 12 yards, total height of 36 feet because we're dealing with feet. So that whole height is 36, but I don't need the whole height. I'm trying to find the area of the triangle and the area of the rectangle. So if the whole thing is 36, but then that you see that little baby height over in the back corner of that barn, that's 4.5, which means that this right here is 4.5. So if the whole thing is 36 and that little baby height is 4.5, then I can do 36 minus 4.5 to find the height of the triangle. So again, if you didn't have a calculator, sorry about you. I'm going to use mine. 36 minus 4.5 is 31.5. So that means that that little height of the rectangle is 4.5, and this height right here is 31.5. What else do I know about this pentagon? I know that the base is 32 because they identify that for us down here. So that bottom is 32. Now I have all the information I need to find the area of a triangle and the area of a rectangle. Area of a triangle is what? 1/2 base times height. Good. Area of a rectangle is what? Length times width. Good. We know those formulas, and we should know those formulas even if you get a reference sheet. Not everybody does, so it's good to just know them. So my area of my triangle is going to be 1/2 base times height because the bottom of that triangle is 32. The top of the triangle, because the bottom of the rectangle is 32. I know the top of the rectangle is going to be 32, which is the base of that triangle. So area equals 1/2 base times height, which is 1/2 times 32 times 31.5. Base is 32, height is 31.5. I'm going to multiply all those together. 31.5 times 32 divided by 2. That gives me 504 feet squared. That's the area of just the triangle. Then I'm going to find the area of the rectangle, which is going to be length times width, which is 4.5 times 32. I'm going to give my poor screen a chance to catch up so I can see where I've written so far. 32 times 4.5 is 144. So we have the area of a triangle is 504. We have the area of the rectangle is 144. Why did we just do all that work? We just did all that work so we could add them together to find the area of the whole base. All of that work just for one base. That's it. So length times width equals 144, and 144 plus 504 equals 648, which equals big B. Then I can just multiply that times height. We already defined height as 45. We did that way in the beginning. Height is the distance from one base to another. So 648 times 45 is 29,160, which is D. Drop any questions that you have as I'm working through this in the chat. I'm more than happy to answer questions throughout this. And also, for those of you who were not here last week, if you have questions on what you're working on in your prep course for Learning Liaisons, or in a study guide, or a question that you saw on the state website, if you have any questions that you want to ask during the live session, I'm more than happy to go off the beaten path from the questions I prepared and answer those. You just have to be able to give me the entire question, because I had someone last week and I feel bad I wasn't able to answer her question, but she was like, well, there was this one question that was kind of like this and I wasn't able to answer. I need an exact question. So if you have questions, feel free to drop them in the chat and I'm more than happy to answer them. All right, so 648 times 45 gave us D as our answer. All right, let's move on to problem number 4. So we've done a lot of middle school, elementary school. This was a solid middle school, high school problem. Let's move on to the next question. Which is definitely more of a middle school, high school question. We're starting to enter into relationships of lines and functions. All right, which of the following describes the relationship between these two lines? Negative 2x plus 3y equals 8, and 4x minus 2y equals 7. So sometimes we're like, what is this question even asking us? So I like to look at my answer choices first just to see which direction we're going. A, perpendicular, B, parallel, C, intersecting but not perpendicular, or D, coinciding. All right, so as soon as I look at my answer choices, I know where we're going with this question. These two equations represent linear functions. How do I know that? Because the x and the y are both to an exponent of 1. They both have an exponent of 1, which means I know we're dealing with a linear function. If the x was squared or cubed, I would know that I was dealing with a parabola or a cubic function or something like that. Now, how do I find relationship among linear functions? I use slope. So we've got perpendicular, parallel, intersecting, not perpendicular, or coinciding. I need to figure out my slope because each of these answer choices has a very specific slope relationship with these problems or with these equations. So perpendicular has a negative reciprocal slope. Reciprocal just meaning the flop of a fraction. So if I have A over B, the reciprocal would be B over A. If I have A over B, the negative reciprocal would be negative B over A. So the negative reciprocal means like if you solved these for the slope and you got negative reciprocals, they would be perpendicular. Parallel lines. What do we know about parallel lines? Parallel lines have the same slope. So if we solve these and we get the same slope, we know these lines are parallel. Intersecting but not perpendicular. If we get a function or if we solve these and we get slopes that are just different, they're not the same, and they're not negative reciprocals, then we know that they intersect, but they're not perpendicular. So just different slopes. And coinciding is the exact same line. So if I simplify these and I get the exact same thing, I know they're coinciding. So let's go ahead and put these. There's a lot of different ways we could do this. The way I like to do it is I like to put it into slope-intersect form. Slope-intersect form is y equals mx plus b. If you're prepping for a middle school, high school, core, GCAT, you need to know that. Slope-intersect form is y equals mx plus b. Mathematicians are not very creative when it comes to that. It's called slope-intercept form because it literally gives you a slope and an intercept. That's why it's called slope-intercept form. So your m is your slope, and your b is your y-intercept. So let's go ahead and manipulate these equations into y equals mx plus b. So we have negative 2x plus 3y equals 8. I'm going to add 2x to both sides because in slope-intercept form, I see that the y is on the left and everything else is on the right. So if I add 2x to both sides, then I can get that x over there and that y is isolated. Just waiting for that screen to catch up. So we see in slope-intercept form, we have our slope is m, our y-intercept is b. It's getting there. And I'm going to add that 2x from the left to the right so that I can end up with 3y equals 2x plus 8. So if I add the 2x to both sides, I get 3y equals 2x plus 8. And then in order to isolate that y, I can divide both sides by 3. And if I divide both sides by 3, then y is going to be by itself. When you divide both sides by 3, you're going to divide the x term and the constant. It's not just one or the other. You're going to divide both by 8. So when I divide both of them by 3, I'm going to get negative 2 divided by 3x, positive 2. 2 divided by 3x equals 8/3. So my slope for this first equation is going to be 2 over 3. Now, perpendicular, parallel, intersecting, or coinciding. I don't know yet. I have to manipulate that second equation in order to figure out if they are perpendicular, parallel, intersecting, or coinciding. As we're waiting for this screen to catch up, drop a comment in the comments for me and let me know if there's any specific topics that you want me to focus on next week. So do you want me to focus on geometry? Do you want me to focus on coordinate planes? Do you want me to focus on probability? Where is your area of struggle? And remind me which course you're taking as well, so that when I'm going through the comments, I don't have to go back and figure out what course you're taking. So if there's a specific area that you want me to focus on next week, let me know in the comments so that I can tailor those question sets for you guys. All right, divide everything by 3, and I get y equals 2 over 3 x plus 8. So our slope is 2 over 3. Now, let's go ahead and start manipulating that second equation. 4x minus 2y equals 7. All right, 4x minus 2y equals 7. So the first thing I'm going to do is subtract that 4x from the left to the right to get that y by itself. I'm not going to divide by -2 yet. I want to get everything else over to the right, and then I want to divide by -2. So we're going to subtract that 4x over and see what happens. Minus 4x minus 4x, and I get -2y equals -4x plus 7. Now that I've got that -2y isolated, I'm going to divide everything by -2. So I'm going to go ahead and divide everything by -2 and see what the slope is so that I can go ahead and figure out perpendicular, parallel, intersecting, coinciding, all of that. Candace, I noticed that you want me to focus on geometry for math 6 through 12. Excellent. Geometry always trips people up. Distance equals rate times time. Yes, such a struggle, especially with like the boats that are going in the same direction, cars that are going in opposite directions. Deductive and inductive reasoning for 5 through 9. Deductive and inductive reasoning for any grade level is always difficult. Definitely will add that to my list. All right, divide both sides by -2, and we get a slope of we get a slope of +2, because -4 divided by -2 is +2. So for our first equation, our slope was 2 over 3. And for our second equation, our slope was just plain old +2. So that means that these lines are intersecting, but they're not perpendicular. So the answer is C. Again, because the slope of the first line was 2 over 3, and the slope of the second line was a +2, which means our answer is C. Excellent job. Let's go ahead and go into problem number 5. Hey, we're doing distance equals rate times time, Susan. That's funny. All right, Mario and Luigi start at the same spot. Luigi's car moves at a speed of 62 miles per hour, and Mario's car drives at a speed of 47 miles per hour in the opposite direction. If both drivers maintain a constant, not contact, constant speed, about how many minutes will it take for them to be 77 miles away from each other? All right, so we've got 2 different cars going in opposite directions of each other. Like I told you before, I love a good picture. I love to draw pictures. So we're going to draw a little picture, and hopefully the screen will stay caught up. So we've got car A, and we'll call that Luigi's car. There we go. And it's going in this direction at 62 miles per hour. And then we've got car B going in the opposite direction, which is Mario's car, going 47 miles per hour. So here's his car. They really look like hats with wheels because I'm not an artist, but that's okay. And it's going this way at 47 miles per hour. Now, there's a couple of different ways we can solve this. We could make a table and we could figure out how far away are they after an hour. But that's not helpful because after an hour, they're going to be more than 77 miles apart because in 1 hour, Luigi's going to go 62 miles this way. And in another hour, in the same hour, Mario's car is going to go 47 miles this way. So 62 plus 47 is 109. So we know that after an hour, they're going to be 109 miles apart. And that's not helpful because we're looking for when they're going to be 77 miles apart. So we're definitely using distance equals rate times time. So let's talk about how we're going to use distance equals rate times time. Just waiting for my screen. Sorry, guys. And distance equals rate times time can apply to a problem like this, but it can also apply to problems like books. Like I've seen problems where it's a very similar problem, but it's like, you know, Maria reads 45 pages in an hour and John reads 72 pages in an hour. How long will it be until they read 300 pages total or something like that? I've seen problems like that, and you can still use distance equals rate times time for problems like that too. Well, my screen is frozen, so that's fun. Distance equals rate times time. There we go. So we know that the desired distance is 77 miles away. That's the desired distance. And we know that the rate for Luigi is 62 miles an hour. And we know that the rate for Mario is 47 miles an hour. So we've got two different rates. And what we're looking for is time. We're looking for how long will it take them to be 77 miles away from each other. So we've got distance equals rate times time, and distance equals rate times time. So we've got distance equals 62 times time, and we've got distance equals 47 times time. Just waiting for it to catch up. I see some people want inverses, even and odd, decreasing and increasing. Perfect. Coordinate plane and functions. Awesome. I'll definitely include some of that. And I may not be able to include all of these requests in next week, but I can definitely include it in the next week. So distance equals 62 times time, and distance equals 47 times time. Now, what is the distance for both of them? The distance for both of them is going to be 77 away from each other. So what we're going to do here come on, computer. Distance equals 47 times t. There we go. All right, distance equals 47 times t. So what we're trying to find is when they're going to be 77 miles. Oh, Lord, now it's writing all on top of itself. Whatever. We all know what that says. Distance equals 47 times t. So now we need to figure out how long will it take for them to be 77 miles away from each other. So I've got Luigi's car going in this direction, and I've got Mario's car going in this direction, but I need them to be 77 miles away from each other. So what I really have is we're adding those two together to be 77 miles away from each other, because while they're going in opposite directions, what's happening is those distances are being added together. Does that make sense? So what I have is a distance of 77 total, because even though they're going apart, what's happening is that distance is just getting bigger and bigger and bigger. So our distance is 7. What is the rate? The rate is going to be how fast they're both going. So we've got 62 plus 47 times that time because they're going away from each other, which means they're going 62 miles an hour and 47 miles an hour. So 62 plus 47, we already decided was 109 miles per hour because that's how many miles they're going to go in 1 hour. So 77 equals 109 is going to be my rate times my time because I'm going to add those two rates at the bottom together to get a distance of 77. Now I can just divide both sides by 109, and you're like, wait a minute, that's going to give me a fraction. You're absolutely right, it's going to give us a fraction because it's going to be less than an hour. So if I divide both sides by 109, I get t equals 77 divided by 109, 0.706. You're like, wait a minute, that's not an answer choice. You're right, because that's the fraction of an hour, because our time is in hours. If I multiply that time by 60, then I can get how many minutes it is, because there's 60 minutes in an hour. So times 60 gives us 42 minutes. So our answer is D. Now, if this problem said that they were moving in the same direction, because they're going in the same direction, they're not speeding away from each other, you would actually subtract those rates from each other. So how long would it take for them to get 77 miles away if they were going in the same direction? We would still do 77 equals, because that's the distance that we're looking for, but we would do 62 minus 47 instead of plus 47. So for those of you who are taking your GK very soon, that's going to be what that is. All right, problem 6. Moving on. Which of the following input-output relationships satisfies the definition of a function? Another 6 through 12 middle school core problem. But elementary teachers, this is helpful for you to understand too, because even though you don't teach functions, you do teach relationships and patterns within numbers. So input-output is the same as X's and Y's. So we've got input X, output Y. I remember that because it goes in the order of the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, A, B, C, D, E, F, G, X, Y, Z. So input is X, output is Y. Which satisfies the definition of a function? A function follows the vertical line test. That's what I always remember because that's so easy to remember. A function has to pass the vertical line test, which means if I have a graph, and I have something that looks like this, if I draw vertical lines through that, what's going to happen? It's going to go, because it's going to hit that graph 2 times, which means it is not a function. But let's actually think about what that means in terms of inputs and outputs. That means that I'm going to go over, and elementary teachers, you can listen to this too because you have to know how to plot coordinate points. What is this point right here? Let's just pretend that's positive 2. So we go over 1, 2, and we go up 0. That point is going to be 2, 0. And then what is this point going to be up here? That point is going to be hop 1, 2, up, maybe 2 as well. So we've got 2, 0, and we've got 2, 4. That's a big problem. We've got 2 of the same X values, which means it does not pass that vertical line test. If I have 2 of the same X values, I'm not going to have a vertical line test that passes. So letter A, not going to work because we have 2 of the same input. Letter B, not going to work. We have 2 of the same X value. Letter C, all different. Letter D, nope, not going to work. 2 of the same X value. So the only input-output relationship that satisfies a function is going to be C. Pretty straightforward if you understand the definition of a function. Let's keep going. Problem number 7. Come on, iPad. I'm so glad y'all are spending your Wednesday night with me. This is so fun. I love doing math with people. It's like one of my favorite things ever. Why are you not swiping? Problem number 7. How many solutions does the equation below have? Now, I can automatically cross off 2. And here's why. Because in order for a equation to have 2 solutions or more, I have to have a degree that is 2 or more. What this means is we're asking for how many times does this equation cross that x-axis? That's what we're really asking. And in this case, it only has the potential to cross 1 time because it's a linear function because our x has a degree of 1. So in order to solve this, we have to simplify this entire equation down to get an x equals something. Let's go ahead and solve it, and then I'll explain when you would get none and when you would get infinitely many. So the first thing I'm going to do is I'm going to distribute my -6 all the way through, and I'm going to distribute my 2 all the way through. So I get -6x minus 12, and then I'm going to keep everything else the same. Minus x plus 3 equals, and then I'm going to go ahead and distribute that 2x. 2x plus 10, and then minus 4. So I distributed my -6, and I distributed my 2, and I kept everything else the same. Then what I need to do is I need to combine my x's, my like terms, and I need to combine my constants, my other like terms. So I need to get all my x's together, and I need to get all my constants together to then be able to figure out what we're working with. Christine, you're welcome. I just saw your comment. I'm so happy that you were able to pass that elementary K6 math test. Thank you. I appreciate the love. All right, -6x minus 12 minus x plus 3 equals 2x plus 10 minus 4. All right, let's go ahead and combine our x's. So on the left side of the equation, we have -6x minus x. What is -6 minus 1, -7x? Because the x's don't disappear, guys. You got to remember, when we add x's together, we're really just adding the constants, and the x's just get to exist with them. So for the left side of my equation, I'm going to have -7x, and then I'm also going to add my constants together. I have -12 plus 3. And remember, if I'm starting at -12 on my number line, and I'm hopping 3 to the right on the number line because positive moves us to the right, I'm still going to be in negative land because I'm not going to hop enough times to get over 0. So I'm going to end up with -9. So on the left side of my equation, I have -7x minus 9. And I'm going to keep everything on the right side of my equation the same. And really, I'm talking through this much more than I normally would just because my poor iPad is taking forever to catch up. So -7x minus 9 equals, and then I'm going to keep everything on the right side of my equation the same. 2x plus 10 minus 4. Now, on the right side of my equation, I only have one x value, so I don't need to combine those. What I do need to do is combine my constants. 10 minus 4 is 6. So I have -7x minus 9 equals 2x plus 6 because it's 10 minus 4. So -7x minus 9 equals 2x plus 6. Now I've combined everything I can on the left and the right. So what I'm going to do is I'm going to move my x's to the left side, and I'm going to move my constants to the right side. So I'm going to subtract 2x from the right over to the left, and I'm going to add 9 from the left over to the right. All right, let's go ahead. Minus 2x minus 2x. Now, the reason I did that is because 2x minus x is 0. It gets rid of it. So that's why I did that on the right side of the equation. And then -7x minus 2x is going to give me a -9x. And I just wrote right on top of my screen because I didn't realize I had already written this. So we're just going to wait for it to catch up for a minute just because I don't want to write on top of what I've already done. All right, negative 7x minus 9 equals 2x plus 6. Then I subtract the 2x from both sides. And I'm going to move up to the top because we're running out of space. So I end up with negative 9x minus 9 equals 6. Now I'm going to add 9 to both sides. So I add 9 to both sides. And I end up with negative 9x equals 15. I feel like I should have like the Jeopardy theme song playing in the background while we wait for the iPad to catch up. Do, 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 do. Negative 9x minus 9 equals 6. Add 6 to both sides and we get negative 9x equals 15. What's going to end up happening here is when I divide both sides by negative 9, I'm going to end up with one solution. It's not going to be a pretty solution, but it's going to be one solution. Now, some of you are like, well, what would have happened if we got no solutions or infinitely many? We already crossed off the 2 because it doesn't have a degree of 2. If this had a degree of 2, high school people, we would have to factor it or use the quadratic formula or complete the square to solve to find both of those solutions. But in this case, it only had one solution. If we got something like 3 equals 7. If the x's canceled out and we solved this whole thing and we got something like 3 equals 7, there would be no solution. Because what that tells us is there's no equality in this equation. However, if we got something like 3 equals 3, it would be infinitely many solutions because what ended up happening is we got an equality statement without the x. So if the x canceled out and we got 3 equals 7, there would be no solution because that's impossible. 3 doesn't equal 7. But if we got something like 3 equals 3 or 0 equals 0 or 2 equals 2 or x equals x, there would be infinitely many solutions. But because that didn't happen and we have negative 9x equals 15, divide both sides by negative 9, and we get x equals 15 divided by negative 9, we have one solution. So that's why the answer is 1 for this specific problem. All right, we have time for one more problem. So I got through 8 problems tonight. If you text the number that was on the screen earlier, I think it was on the screen earlier. If it wasn't, it'll pop up in a little bit. Then you can get the PDF of all these problems and you can get 2 more bonus problems. You can get the 8 and the 9. There it is. Want the slides? If you text that number, you can get these slides and you can get the 2 bonus problems at the end too. And if you want to know how to solve those, feel free to reach out to me on our Facebook page and I'll be happy to help you with that if you need help with those. All right, problem number 8, final problem of the night. Thanks for sticking around this long. And don't forget, when I'm done with the problems, stay tuned at the very end for a special message from Jason again, or Dr. A. Just waiting. Do, 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 do. All right, I don't see that anybody has any questions as of yet. Like I said before, feel free to bring your questions with you to any live math sessions on Wednesdays, and I'm more than happy to go off the beaten path and solve any questions that you guys may have that you post in the comments. So feel free to do that. All right, a very similar problem, which is perfect because we actually don't have a whole lot of time left. How many real solutions does the equation below have? Now, I could spend time trying to factor this. I already know that this doesn't factor because in order to factor this, and I'm going to go through this a little bit quickly, so if you are not familiar with factoring, I highly encourage you to go watch a factoring video if this is on your exam. This is more of a 6 through 12 problem, maybe a little bit of 5 through 9, depending on where you're taking it. I know this doesn't factor because 1 and 40 aren't going to give me negative 5, 2 and 20 aren't going to, 40 is not divisible by 3, 4 and 10 are not going to, 8 and 5. So I know this doesn't factor. So I could use the quadratic formula, but I actually don't have to use the entire quadratic formula. I know that the quadratic formula says negative b plus or minus the square root of b squared minus 4ac all divided by 2a. But what part of that quadratic formula tells me the number of solutions? The discriminant tells me the number of solutions. The discriminant is the b squared minus 4ac part because it's under that square root. So the discriminant is the b squared minus 4ac, a being 1, b being negative 5, c being 40. Why does that tell me how many solutions I have? Well, because if I get a negative number under that square root, I'm not going to have any real solutions. I can't take the square root of a negative number, so I would only have imaginary solutions. If I got the square root of 0, well, plus 0 and minus 0 are going to give me the same thing. So that would be one real solution. And if I got the square root of a positive number, no matter what kind of positive number it is, it doesn't have to be a pretty positive number, I'm going to have two real solutions. So if you're looking for how many real solutions an equation has that's a quadratic, you can just use the discriminant. There's no reason to go through that entire quadratic formula to solve it. Let's go ahead and do it. B is negative 5. So I have negative 5 squared minus 4 times A times C. Remembering that A is 1. It's the constant with the x squared, or the coefficient, sorry. And C is the 40. It's that constant. It's the number at the end. So negative 5 squared minus 4 times 1 times 40. Negative 5 times negative 5 is 25. So I have 25. And then negative 4 times 1 is going to be negative 4. And then negative 4 times 40 is going to be negative 160. So what I have is 25 minus 160. Well, that's interesting. Is that going to give me a positive or a negative number? I don't even need to whip out my calculator for that. 25 minus 160. I don't need to solve that. It's a negative number. It doesn't matter what kind of negative number it is. I can't take the square root of a negative number. And remember, this discriminant is that part of the quadratic formula that's under that square root. Because I can't take the square root of a negative number, it means I have no real solutions. They're all imaginary. Therefore, the answer is A. Alrighty, guys. Thank you so much for joining. I'm going to throw it back to Dr. A, and I will see you guys soon. Remember to bring some problems with you. I'm actually going to, before I throw it back to him, take some pictures of what you guys want me to focus on, and then we are going to say goodbye for now. So, Dr. A, it's back to you, and I will see you guys later. Thank you so much for joining.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.